Hello students, in the last lecture we have started coordination compounds and introductory points about the coordination compounds in the last lecture we have studied. For example, what is coordination complex or compound? Coordination complex is a compound in which a central metal atom or ion is surrounded by number of ligands, and in it we have studied what is meant by ligand and various type of ligands. So different types of ligands like the monodentate ligand and polydentate ligand we have studied. Polydentate ligands again are of different types, that is the bidentate ligand have two donor site, or it can donate two pairs of electron to central metal atom ion. Tridentate ligand, tetradentate ligand and hexadentate ligand with example last time we have studied, as well as we have also studied ambidentate ligands and its example also in the last lecture we have studied. Now also we have studied terms in coordination complex or coordination compound we have studied, that is the inner sphere, that is the which is written in square bracket. It is rigid called as coordination sphere, and outer sphere which is written outside the square bracket, it is the ionization sphere, and with example we have studied in the last lecture about the coordination sphere and ionization sphere. Today some another points about the coordination complex or coordination compounds we have to study, that is what is charge number of complex ion and how to find out the metal oxidation state of metal ion in that coordination compound, coordination complex, that we have to study. So see, first of all, charge number of complex ion. Charge number of complex, that is the net charge. Charge number is the net charge residing or occurring by or on a complex, is the charge number, that is the charge number. So what is the net charge present on that complex? That is called as the charge number. What is the charge acquired by that complex? Overall charge, net charge acquired by that complex is called as the charge number. It is known as the charge number. And on the basis of this charge number, it may be cation present on that complex, maybe anion present on that complex, or sometimes no charge present on that complex. So on that basis there are cationic complexes, anionic complexes, and if there is no any charge on the complex, it is neutral complexes. So here see, for example, you see here FeCN/6, here 4 minus charge present on this complex. So in this complex, charge number on that complex ion is minus 4. Or next one example, CuNH3/4, here plus 2. Then in this charge number is what, that is the plus 2, like this. That is called as the charge number. That is known as the charge number. Or here you see cisplatin. This example last time we have studied by 2 here, Cl2. In this case, charge number on that complex is 0. No charge acquired by that complex. Net charge on that complex is 0, and therefore that is the charge number is 0. So you don't forget, net charge residing on that complex ion, net charge acquired by that complex is called as the charge number, So on this complex the charge acquired by that complex is -4. Here on this complex charge acquired by the complex is +2, therefore charge number is +2. Here on this complex there is no charge, means zero charge, it is neutral complex, therefore here its charge number is 0, that is charge number is 0. Now see the oxidation state of metal ion is what, that is the oxidation state acquired by the metal, it is nothing but the charge acquired by what, that is the metal ion, charge acquired by the metal ion in a complex that is called as what, that is the oxidation number. What is the charge acquired by that metal ion in a complex? It is called as the oxidation number of that metal ion. That is the oxidation state of that metal ion. And how will you find out the oxidation state of metal ion? Here it should be remembered that is the net charge on complex ion is equal to sum of the oxidation state of all species in that complex. वो complex में जितने भी species है metal ion and all ligand. So what is the sum of oxidation number of the charge present in that coordination complex? That is nothing but the net charge present on that complex. Sum of oxidation of all species in coordination sphere is equal to the charge acquired by that complex, or which is equal to net charge on that complex, right? So here if you take this example, first one, that is FeCN/6, here 4 minus, right? Now according to this formula, the sum of oxidation state of Fe plus 6 into oxidation state or charge on what, that is the cyanide ion, right, equal to -4, that is net charge on this complex. Now we don't know the oxidation state of Fe, so oxidation state of Fe plus 6 into charge on cyanide ion is -1, therefore -1 is equal to -4, and therefore oxidation state of Fe is equal to -4, this -6 to that side +6, and that is nothing but the +2. So oxidation state of Fe in that complex is +2. Oxidation number of Fe in that complex is +2. In this way, oxidation number of oxidation state is determined. So you don't forget, sum of the charges of all species present in complex ion in coordination complex is equal to net charge on that complex, and in this way we can find out the oxidation state or oxidation number of metal ion in that complex. Now you see second one example, that is the CuNH3/4 having +2 charge. Here oxidation state of copper plus 4 into oxidation or charge on ammonia is 0, because ammonia molecule is neutral, which is equal to +2, and therefore oxidation state of copper is equal to +2. Oxidation state of copper, oxidation number of copper is +2. Or we can take another one example, that is this one. Which one? That is the platinum NH3 by 2 and here Cl2. Now net charge on this complex is 0. This complex is neutral complex. Okay. So here oxidation state of platinum plus 2 into oxidation state or charge on the ammonia is 0 plus 2 into charge on chloride ion is minus 1 which is equal to 0. So platinum minus 2 equal to 0. So here platinum oxidation state is equal to plus 2. Oxidation state of platinum is equal to plus 2. So you don't forget that sum of the charges of all the species present in that complex or coordination sphere which is equal to net charge present on it. Sum of the oxidation number or what that is the charges present in that complex of all species equal to net charge on that complex. That is the net charge on that complex, and in this way we can find out, we can determine oxidation number of metal ion present in that coordination compound or the complex. So this is about the charge number of complex ion and oxidation number or oxidation state of metal ion. Okay. So to find out the oxidation state of metal ion, we should know what is the charge present on that complex, and second thing, we have to do the sum of charges of all species present in that coordination complex. Then we can find out the oxidation number of metal ion present in that coordination compound or coordination complex. Now see next one number, coordination number of central metal atom or central metal ion in that species. See the number of ligands directly attached or number of electron pairs donated by ligands to the central metal atom is called as the कोऑर्डिनेशन कॉम्प्लेक्स में, कोऑर्डिनेशन कंपाउंड में जो भी सेंट्रल मेटल एटम होता है जो कि कोऑर्डिनेशन कंपाउंड फॉर्म करता है. नाउ यू हैव टू रिमेंबर दैट D block element or transition element have high tendency to form the coordination compound. Why they have high tendency to form coordination compound? Because they have vacant d orbital in their outermost shell, and in the formation of coordination compound we know ligands donate electron pair to central metal atom, और वो central metal atom के पास लिगेंड ने जो इलेक्ट्रॉन पेयर डोनेट किए हैं वो लेने के लिए वैकेंट ऑर्बिटल है, और उस वैकेंट ऑर्बिटल में लिगेंड के इलेक्ट्रॉन को एक्सेप्ट करते हैं, रखते हैं, एंड देयरफॉर दे हैव टेंडेंसी टू फॉर्म द कॉम्प्लेक्सेस, व्हाइल एस ब्लॉक एलिमेंट एंड पी ब्लॉक एलिमेंट हैव नो टेंडेंसी टू फॉर्म द कॉम्प्लेक्सेस एक्सेप्ट फ्यू मेटल. सो क्या होता है, जो भी इलेक्ट्रॉन पेयर सेंट्रल मेटल एटम को लिगैंड डोनेट करते हैं, इन केस ऑफ मोनोडेंटेट लिगैंड डायरेक्टली, मोनोडेंटेट लिगैंड अगर मेटल आयन को अटैच है तो उस मेटल एटम को और आयन को, सेंट्रल मेटल एटम और आयन को कॉम्प्लेक्स में डायरेक्टली हाउ मेनी मोनोडेंटेट लिगैंड्स आर अटैच, दैट इज इक्वल टू इट्स कोऑर्डिनेशन नंबर. मोनोडेंटेट लिगैंड जितने अटैच है सेंट्रल मेटल एटम को और आयन को, वो डायरेक्टली उसका कोऑर्डिनेशन नंबर होता है. मगर बाइडेंटेट लिगैंड और पॉलीडेंटेट लिगैंड में ऐसा नहीं है. तो पॉलीडेंटेट लिगैंड में क्या होता है कि पॉलीडेंटेट लिगैंड में एक लिगैंड दो और दो से ज्यादा इलेक्ट्रॉन पेयर डोनेट कर सकता है. सो एट दैट टाइम to find out coordination number, you have to taken into account number of electron pair donated by the ligand. So point to be noted. What? In case of polydentate ligand, you have to taken into account how many electron pairs are donated by that ligand, and therefore number of ligand directly attached to the central metal atom or ion, or number of electron pair donated by ligands to that central metal atom or ion is called as its coordination number, is known as its coordination number. Okay, here to take this example, that is Cu, here NH3 by 4, here charge on this complex is +2. Now we have to find out the coordination number. Ammonia is monodentate ligand, and how many ammonia molecules are attached to this copper +2 ion? 4, and therefore coordination number of copper is equal to 4 in this complex. Coordination number of copper is 4. Now second example we will take here, FeCN by 6 having 4 minus charge. Here cyanide ion also monodentate ligand, they have -1 charge and they can directly donate one pair of electron to central metal atom or ion. Therefore here coordination number of Fe is 6. Coordination number of Fe in this complex is 6. Why? Because 6 monodentate ligands are directly attached to Fe. 6 monodentate ligands are directly attached to ion. Or you take this example, that is nothing but what, that is the Cu C2O4. Here what, that is the 0, that is the C2O4. Here what, that is the by 2, and here 2 minus charge. Now carbon, it is the carboxylato group. This is the oxalato group. One oxalato ligand can donate 2 pair of electron, right? So here how many oxalato group? 2. So 2 oxalato group or ligand will donate how many pair of electron? 4. And therefore coordination number of copper in this complex is what, that is the 4, because it is bidentate ligand. This is bidentate ligand. Or you see this example, COEN by 3, and here charge is what, that is the +3. Charge on complex ion is +3. We have to find out the coordination complex. Here En for ethylene diamine, it is what, that is the ethylene diamine, and this ethylene diamine is bidentate ligand. Bidentate ligand means one ligand of ethylene diamine can donate 2 lone pairs of electron. Therefore 3 ligands or 3 ethylene diamine will donate how many pairs of electrons? 6, and therefore coordination number of cobalt in this complex is what, that is the 6. You don't forget it. That is the coordination number of the cobalt ion is 6. Coordination number of cobalt ion is 6. In this way, this is nothing but the coordination number. Or you can take this one, CrC2O4 by 3. Here what, that is the 3 minus. I think 3 to the 6, that is the 3 minus. Yeah. Chromium have coordination number 6 because oxalato group can donate 2 lone pairs of electrons. Means one oxalato group if attached to the chromium, then its coordination number 2. So 3 oxalato group will have coordination number 6. Will have coordination number 6. Or you take this example also, CONH3 hereby 4 Cl2. Here what, that is the +1 charge. Now here how many monodentate ligand attached to cobalt? That is the 4 ammonia molecule plus 2 chloride ion. Coordination number of cobalt is 6 here. Coordination number of cobalt is 6, and like this we can determine we can find out the coordination number of central metal ion like this. Coordination number of central metal ion like this. You see here Zn Cn by 4, here charge on this -2, and suppose if question is asked that what is the oxidation state of zinc in this tetracyanozincate 2 ion. Okay, so here oxidation state of zinc plus 4 into charge on cyanide ion, equal to -2, because sum of the charges of all species present in that complex is equal to charge on that complex, So oxidation state of zinc plus 4 into -1 equal to -2. Oxidation state of zinc equal to -2 plus 4. Here -2 और this -4 उस साइड को गए तो +4. Therefore oxidation number of the zinc in this complex is +2. So in this way we can determine oxidation number as well as the coordination number of a central metal ion in a complex by using this rule, by using this formula. Now we have to study next one point is that what that is the double salt and coordination complex. What is meant by a double salt and what is a coordination complex? That point now here we have to study. See. Double salt and coordination complex. Double salt and coordination complex. So when two or more than two salts combines, then there is formation of the complexes. But sometime two or more salt if combines, then that may not be complex. It may not be complex. So that here we have to study. Two or more stable compound, when combines in a stoichiometric ratio, then there is formation of complex. As well as sometime two or more stable salt combines, but there will be no formation of complex. Then how will you identify, how will you decide whether that is double salt or it is not a complex or it is a complex? So that is we have to study. What happens actually, double salts in water undergoes complete ionization, complete dissociation we can say. Double salt undergoes the complete dissociation. And what are the ions present in that salt? All they are dissociate, all they are produced in the solution. Okay? There is no any unionized ion present in it, all ions will be formed in its aqueous solution. So here we will take the example like what that is the ferrous ammonium sulfate. Here you see FeSO4 ammonium sulfate NH4 by 2 SO4 and it contains 6 moles of water. And when this salt is added in water, अगर हमने इस डबल सॉल्ट को वाटर में ऐड किया, एक्सेस ऑफ वाटर में, तो इसका एक्वियस सॉल्यूशन में there will be formation of all ions. Which ions are present in the salt? Fe+2 ion are present, ammonium ions are present, and sulfate ions are present. All that ions will be produced, all that ions will be formed in it. Here see, there is formation of Fe2 plus ion in its aqueous state, in its aqueous solution. Then there will be formation of ammonium ion, NH4 plus ion. Here see, ammonium ion. Here there is formation of Fe2 plus ion, as well as there is formation of sulfate ions in their aqueous state. So if that substance undergoes complete dissociation in its aqueous solution and there is formation of ions which are present in its molar compound or in its molecule, all ions are formed, then it is double salt. Or see another one example, that is the kernelite. Here we have to take. We have to take the example of what that is the kernelite, means this one, that is kernelite. Kernelite have this formula KCl MgCl2 contains 6 moles of water. This is also called as what, that is the Mohs salt. Ferrous ammonium sulfate is called as Mohs salt. Now you see this KCl MgCl2 containing 6 mole of water as hydrate added in excess of water, then there will be formation of K plus ion plus what, that is the Mg2 plus ion plus 3Cl minus ion in aqueous medium or in aqueous state is formed. So there is complete dissociation of this kernelite or potassium magnesium chloride containing 6 mole of water. So it is double salt. It is double salt. But what happens? What happens in coordination complex? In case of coordination compound, in case of coordination complex, there is no complete dissociation or ionization. Only here only 2 ions are formed. A single coordination complex ion. A single coordination complex ion is formed there, and 1 ion is formed from आयोनाइजेशन स्पेयर. आयोनाइजेशन स्पेयर में जो भी स्पेसीज है वो स्पेसीज से एक टाइप का आयन फॉर्म होगा और एक सिंगल कोऑर्डिनेशन कॉम्प्लेक्स का आयन फॉर्म होगा, यानी कि 2 आयन्स फॉर्म होते हैं खाली. बट व्हाट आर द स्पेसीज प्रेजेंट इन कोऑर्डिनेशन स्पेयर? दैट नॉट अंडरगोज द आयोनाइजेशन, दैट नॉट अंडरगोज द डिसोसिएशन. व्हाई? बिकॉज इट इज रिजिड. The bond between metal ions and ligand is stable, it is strong, that is the coordinate covalent bond is formed. Therefore, that not undergoes the ionization, and hence this is the basic difference in double salt and coordination complex. So we will take one example here to study what that is the coordination complex, how undergoes dissociation. K4 FeCN by 6. So this will ionize or dissociate. Now this is a ionization sphere. 4 K plus ion, it is added in water, and here there is formation of FeCN by 6, 4 minus charge. You see here Fe and Cn ions not dissociate, they are not separated. They are not separated. They are still present in this complex ion. So it is complex coordination compound. It is the coordination complex. See another one example, that is CuNH3 by 4 and here SO4. This is when added in water. Then here there is formation of CuNH3 by 4. Here 2 plus charge. And here SO4 2 minus charge. Sulfate ions are present in ionization sphere. इस complex में this is the coordination sphere, okay, and this is the ionization sphere. अभी इस ionization sphere की जो ions है वो separate हो गए इस complex से, water में ऐड करने के बाद ये ions separate हो गए. तो डिसोसिएशन इस स्पेसिस का नहीं होता, जो भी स्क्वायर ब्रैकेट में स्पेसिस लिखी होती है, जो भी स्क्वायर ब्रैकेट में स्पेसिस रिप्रेजेंट हम करते हैं उसे कोऑर्डिनेशन स्पेयर कहते हैं। वो रिजिड होता है, उसमें बॉन्ड स्ट्रांग होते हैं, सो दैट नॉट अंडरगोज द डिसोसिएशन, दैट नॉट अंडरगोज द आयोनाइजेशन, एंड देयरफॉर दिस इज द कोऑर्डिनेशन कॉम्प्लेक्स। यू डोंट फॉरगेट, दिस इज नथिंग बट द formation of the single species by coordination complex and one species by the ionization sphere. It is the coordination complex. One more example I would like to tell you, that is Na2 Zn Cn by 4. This is sodium zincate. Commonly it is named as sodium zincate. Now here there is formation of 2 sodium ion plus Zn Cn by 4, here 2 minus charge. Okay, so here this is one complex ion species formed and this is one sodium ions are formed, but the species, that is metal ion and ligands present in the coordination sphere, that not undergoes the dissociation, that not undergoes the ionization, so that is nothing but the coordination complex, and this is nothing but the difference in double salt and coordination complex. Thank you.